Hello mathematicians, puzzlers, and other curious people. This problem from the Math 0325 second exam review guide is about stem and leaf plots. So this problem has a few different parts. In the first part, it asks how many people bought a number of boxes in the 20s. Now remember, the way a stem and leaf plot works is the stem over here is basically the tens place, and the leaf over here is basically the ones place for a particular number. So for example, there was, for this right here, this 5 in the ones stem means that if we have a stem of 1 and a leaf of 5, that somebody in this sample bought 15 boxes. So if we're curious about the 20s, we need to look for numbers with a 2 in the tens place, and that would be these right here. So there's a 21, another 21, a 22, another 22, etc. When it asks how many people, we can just count the leaves. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That tells me 10 people bought a number of boxes in the 20s. The next it asks us about is the median. So let's see what's going on there. So conveniently, a stem and leaf plot has the numbers nicely organized in order. So that can help us out with coming in from the ends and squeezing together to find the median. Because remember, the median is the number that's in the middle when they're in order. Now, we might have to split between the last two numbers if it turns out that there end up being two numbers in the middle. But first, to find out if we need to do that, we just need to squeeze in from both sides to the middle. So let's do that. So I know this 45 here isn't the median, and I know this just 5 here is also not the median. So that's squeezing in from the sides. Next, I can squeeze in by 2 at a time because I know the 8 and the 9, also the 36 and the 37 are both the extremes, the things we would be next to squeeze in past. Doing more than one at a time can come in handy if you're trying to work quickly through a problem. So we can also take out these 6, the 30, 31, 32, 33, another 33, and 35, and these 6 here to balance. So a 13, a 15, a 16, a 17, an 18, and another 18. Now I need to switch colors again. So I see we've got a 19 and another 19. We've also got a 21 and another 21. So we can get rid of those together. And now we're getting pretty close to the end of this problem. So let's see, I know we can get rid of those two 22s and this 29 and this 28. And then a 23 and a 28. And I see we do end up with two numbers in the middle here. So remember, that's really 24 and 25. Halfway between them would be 24 and a half or 24.5. Now that one was pretty easy because they were just neighboring numbers, counting numbers like that. But if it's not so simple, what we could also do is say, okay, we can take their midpoint by adding and dividing by how many we added. That's the same as the formula for the average, just of what happens to be two things. We can then grab our calculators and say, okay, 24 plus 25 divided by 2. If your calculator doesn't put it in a fraction display and you punch in 24 plus 25 divided by 2, however, you'll get something different. Have an input here. Okay. So if you do just 24 plus 25 divided by 2, you'll get 36.5, which can't be right because that's more than either of them. That'd be way up here. We know that can't be right. What we need is 24 and 25 added together before we divide them by 2. And that will give us 24.5, just like we expect by splitting it down the middle mentally. And if your calculator does have a fraction display, putting it in without the parentheses will work just fine. If it doesn't, just use the parentheses. You won't even hurt anything by putting the 2 also in parentheses, but it just doesn't matter because it's only the one number. So either of these 2 right ways to put it in will give you the same answer that we got by splitting it down the middle mentally. The only one that will mess you up would be this way right here. That would apply the order of operations in a way we don't want actually this particular problem to have. So we know now that the median is 24.5. Okay, now what about the mode? Let me just move these marks out of the way. And we don't really need them for anything else. So for the mode, that's when we're looking for whatever there's the most of. So I see that there are 2 of a few things. So I'm just going to go through and cross out everything there's only 1 of. And then within those 2, those pairs of the same thing, let's see. So I see that there are 2 each of many different things, but there aren't more than 2 of anything. If there were 2 each of only 2 different things, I'd say that we have a bimodal distribution here, meaning that there are 2 different modes. But since there are only 2 each of many different things, it would make more sense to say that there's not a mode, because nothing really stands out as there being the most of it. Finally, the range. Now the range is super easy to calculate as long as you know how. So it's one of those things that it's not something you would easily come up with by inventing it, but once you see it, it's actually super easy. So the range is just the difference, so we're subtracting, between the maximum and the minimum. If we spread these all out on a dot plot or a line graph and we measured off the distance that this data set goes across, that would be the distance between the maximum and the minimum. Since it's not convenient to have to do all that drawing, it's more convenient to just do one simple subtraction. So what's our maximum? Well, we look to the highest stem and we take that leaf. So I see that that would be a 5 in the ones place within the 40s, so 45. Now when we go to find out the minimum, we come to the lowest stem, but then we have 3 options of leaves. So since we want the minimum, we choose the lowest leaf on the lowest stem. So that would just be 5. So we've got 45 minus 5, so that tells me the range is 40.